Hi guys, welcome to day 2 of Light Hub Maths Academy. As you can see on the screen, our topic is LCM and HCF. And under this section, we are going to be studying the keywords. These keywords, we need to familiarize ourselves with it because as we go through the course of the study, we'll be meeting these words and we need to know them for better understanding. I move further. The acronym for LCM and HCF is lowest common multiple and highest common factor, respectively. So on our keyword list, we have factor, multiple, prime number, and prime factor. Under this section, the goal is for us to know the meaning of these words and know how they function, what they are. Now, factors. The factors of a number are the whole number that divide the number exactly without remainder. Let's take 12 as a case study. You can see these are the factor pairs of 12. These numbers, once we multiply them together, you see it gives us 12. 1 times 12, 12. 2 times 6, 12. 3 times 4, 12. These factors pairs, they are gotten on the multiplication table. They are gotten through the multiplication table. So to prove the point of when a number that divides a whole number, that gives it a perfect number without a remainder. If we divide 12 by 12, we get 1. If we divide 12 by 6, we get 2. If we divide 12 by 2, we get 6. If we divide 12 by 3, we get 4. If we divide 12 by 4, we get 3. This is how the factor works. It gives us perfect number without remainder. That is how you know a factor. We move to multiples. A multiple of a whole number is obtained by multiplying it by any whole number. For example, 18 is a multiple of 3 and 6 because 18 is equal to 3 times 6. Yes, if you multiply 3 times 6 together, you get 18. Why? Why is 18 called the multiple of 3 and 6? If you go through the section of your multiplication table, which is always written at the back of our exercise books, you go through that section. If you go through the section of 3, where 3 is written, the multiples of 3 is written, you find 18 under it. And if you go through the section of 6, you find 18 under it. That is why 18 is a multiple of 3 and 6. We move further. Prime number. The third aspect on our list is prime number. A prime number is a number that has only two factors, which are 1 and itself. Unlike 12, which is having like roughly 6 factors, is having 6 factors. But these numbers written under here as examples, they are numbers that have only two factors, which are 1 and itself. When you look at your multiplication table and you're looking for the factors of this number, you find them that they are only under a particular section. When you go to the section of 2 in the multiplication table, you find out that 2 is just only in one place, which is 1 times 2. And the factor of 2 is 1 and 2, 1 and itself. So is it for other numbers listed under this example. So example of this prime numbers are 2, 3, 5, 7, 11, 13, and 17. These are examples of prime numbers. We move further. We have prime factor. A prime factor is a factor that is also a prime number, just like joining factor and also prime number together. That is what makes the prime factor. For example, the factors of 12 listed above, the prime factors are 2 and 3. Looking at this factor, let me go back so I can get a clearer view. So these are the factors of 12. And as we can see, the prime factors are 2 and 3. Why? Because all these on the page, on your screen right now, all these numbers qualify as factors of 12. But the prime number among them is called the prime factor. It is prime and is also a factor. It is a prime number and it is also a factor. That is what it simply means. So we move to the next session. Thank you very much. This is the working aspect. So, for example, if they ask you to find the LCM and HCF of 16, 12, 4, and 8. So, we're going to find the HCF and the LCM using two methods. There are two methods in working this out. So, the first method, method 1, we will be working the LCM and HCF of method 1. So, the method 1 is a tabular format, like this. So this is for the LCM: 16, 12, 4, and 8. So for the LCM, we will now start dividing with the prime factor. I talked about prime factor. 2 is a prime factor because it can divide this and is a prime number. So 2, let's start with 2. And they are all even numbers. That's why I can use 2 to divide it. 2 in 16, that is 8. 2 in 12, that is 6. 2 in 4, that is 2. 2 in 8, that is 4. 2 can still go. 8 divided by 2, that is 4. 6 divided by 2, that is 3. 2 divided by 2, that is 1. 4 divided by 2, that is 2. I move further. 4 divided by 2, that is 2. 2 cannot go, 3 cannot be divided by 2, so 3 drops down. And also 1 drops down because it has been exhausted. 2 divided by 2, that is 1. 2 can still go because there is a property of 2 here. I use 2. 2 divided by 2, 1. 3 drops down. 1 drops down and 1 drops down. Now we have 3 left. So 3 is a prime factor. It is a prime number and it's a factor because it can divide this. 3 here. 1 drops down. 3 here, 1, 1, 1. So the LCM, therefore, LCM is equal to 2 times 2 times 2 times 2 times 3. So 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 3. So 16 times 3, I'll work it in my small rough corner here that I've carved out. So 16 times 3. 3 times 6, 18. Drop 1. 3 times 1, 3 plus 1. That is 4. So our answer is 48. So very quickly, I'll move to the HCF using this tabular method. So finding the HCF, I have 16, 12, 4, and 8 here. This is the HCF, LCM. So using this method, for the HCF, we are going to use prime factor also to divide it through. What can divide all of them at once? So I'll use 2. 2 is an even number because, all these are even numbers. So 2 is the right prime factor that can divide them all. 2 in 16 divided by 2, that is 8. 12 divided by 2, that is 6. 4 divided by 2, that is 2. 8 divided by 2, that is 4. Then 2 can divide all of them at once. I still put 2. 8 divided by 2, that is 4. 6 divided by 2, that is 3. 2 divided by 2, that is 1. 4 divided by 2, that is 2. There is no other number that can go through, divide everything at once. So I stop here. So HCF, therefore, HCF is equal to 2 times 2, which is equal to 4. That is the answer of the HCF. Now, looking at this tabular method, you can see in the LCM, I exhausted all the numbers. I divided them through till they all reached 1. I exhausted them. But in the HCF, I did not exhaust all the number. What can go into it at once? That's what I use in dividing all of them. And where all the numbers cannot be divided by a single prime factor, I stop there. So this is the tabular method 1. So A, B. Let me divide it properly. Yes. All right. Without no further wasting of time, I'll move to the method two. This method two, we are going to be using the product of the prime factor to find our LCM and HCF. So I'm still using this question. This question. So we are starting from the LCM. So first of all, we look for the product of the prime factor of each numbers. Then we can now find them. So first I'll use 16. So it's 16 divided by 2, that is 8. 8 divided by 2, that is 4. 4 divided by 2, that is 2. 2 divided by 2, that is 1. I move to the second one. I want to look for the product of the prime factor of this. 12. I'm using 2 because 12 is an even number. So 12 divided by 2, that is 6. 6 divided by 2, that is 3. 3 cannot be divided by 2. So what prime factor is next? I'll use 3. 3 is the next. 3 divided by 3, that is 1. So without no further waste of time, I will look for the product of the prime factor of 4. So 2 can divide. 4 divided by 2, that is 2. I also write 2 here because an even number. 2 divided by 2, that is 1. So the last one, let me put it down here. For 8. 8 divided by 2, that is 4. Why am I using 2? Because it is an even number. Let us not forget. 4 divided by, I write 2 here. 4 divided by 2, that is 2. Also write 2 here. 2 divided by 2, that is 1. That is for all of them. This method 2. I've found the prime factors. So now I write the product of the prime factors down. When I say product of the prime factor, product means multiplication. So 16. I write down these factors that are here. Down. 2 times 2 times 2 times 2. That is for 16. For 12, I also write the factors here. 2, 2, and 3. 2 times 2 times 3. For 4, I write the factors that are here on this line. That's 2 times 2. For 8, I also write the factors that are here on the line, on this side, this aspect. 2 times 2 times 2. So this is what is called product of the prime factors. So I write this in multiplication form. So right now I'm going to put each of them in index form. When I say index form, I'm going to raise it to a power. So this will be 2 raised to power 4. Why? Because there are 4 2's here. The 2's that are here are 4. 4 in number. Then this, I have 2 2's and 1 3. So 2 raised to power 2 times 3. Then this, I also have 2 raised to power 2. Raised to power 2. This, I also have 2 raised to power 3. Now that I've successfully put everything in index form, we are now going to pick the factor with the highest index. That's what we're going to use for this LCM. The factor with the highest index. So for number 2, which number has the highest index? This is 2 raised to power 3, 2 raised to power 2, 2 raised to power 2, 2 raised to power 4. So 2 raised to power 4, I'm picking this because it has the highest index. And for 3, this is the only 3 we are dealing with in the whole HCF. I'll pick this. So we are going to multiply our what we circled. So 2 raised to power 4 times 3. So 2 raised to power 4. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 3 is equal to 48. You can see the answers are the same. So this is method 2 for working LCM. LCM. So we move to HCF. HCF also, for all the numbers, we find their prime factors. We write it down this way. So we also write it down this way for HCF. So let's go. HCF. Write it down. 16 is equal to 2 times 2 times 2 times 2. And also 12 is equal to 2 times 2 times 3. And 4 is equal to 2 times 2. And for 8, we are having 2 times 2 times 2. So that is all. And for HCF, we are going to pick the one that is common among all numbers. So for this is common. Yes, it's common among the 4 numbers. So write it down. Let's put it. HCF is equal to 2. We've gotten just one. We've written 2. And also another 2 is common in all the number. We'll circle everything. Can you see? So 2 is also common again. Times 2. We just pick one of the 2. Just write it here. Is there any number common? Is 3 common? Any other 2 common? No. All these ones are just extras. So our HCF is equal to 4. As you can see what we got here. So now in this method, the difference between the LCM and the HCF is that in the LCM, we pick the one with the highest index. And for the HCF, we pick the one that is common among the prime factors of the 4 numbers. So that will be all. Thank you.
I know you learned a lot from this video. Please like, share and subscribe. Waiting to see you in the next video to learn more. Bye.